Hello, welcome to the first video tutorial of this series of tutorials of statics. In this video, we'll solve 10 problems about the force systems, forces in a plane, forces acting in the XY plane. So let's start our tutorial, and with the first problem is, as we see, cable stays AB and AD help support pole AC. So we have the pole which is supported by two cables AB and AD. Knowing that the tension is 120 pounds in AB and 40 pounds in AD, determine graphically the magnitude and direction of the resultant of the forces exerted by the stays at A using the parallelogram law, triangle rule. So we'll start with the parallelogram law. First, when we start graphical solutions, first thing we should do is to find or to determine the drawing scale. What's the meaning of the drawing scale? Look at the given figure here. We notice that we have dimensions in feet. So these dimensions do not fit in the paper which we'll use in solving this problem. So we should make a scale, a drawing scale. For example, as we see here, we suppose that every inch on the paper is equal to 10 feet on the figure. So let's start. At the very beginning, we construct the shape we have to scale, because it's very important to draw the angles exactly. So here we don't have angles given as numbers, but we have dimensions, vertical and horizontal dimensions. So that's why we should draw them correctly. You could compute the angles by using the dimensions and the tan inverse or arctan of these values. But let's, in this part, instead of computing the angles, let's use the dimension given in order to construct, let's say, the structure of the solution. Now, we have the dimensions. 1 inch vertical is equivalent to 10 feet here, 0.6 inches and 0.8 inches in order to have the exact shape on the paper. Now, we can define the angles, but we will use those angles in the next part when we use the triangle rule. But just we know that here the angle alpha and we have here the angle beta. Now we can start drawing the forces. In order to draw the forces, also we need another scale, which is the force scale. So here we suppose that every inch on the paper will equal to 40 pounds at the given problem. Why? Because actually we will represent the forces as arrows or vectors, and the length of the vector is proportional to the value of the force. So actually, in order to have representation, correct representation, we should fix the force scale that the force will be drawn by on the paper. So the first force, FAB, will be equal to 120 pounds multiplied by 1 inch over 40 pounds. Here it's very important to know how to make our conversions from the force to dimension on the paper, because here just want to use the idea that we multiply the value of the force by the scale as a ratio in order to neglect the two force units, and then we will get the only on the numerator the length unit, and we'll get the value correctly. The same thing here, we multiply the value in a way that the force units are cancelled in order to get the length unit in this case. So in this case, we will draw a line or an arrow starting from the point A along the line AD, which will be FAD, and FAB in this way. So you see here, we draw, this is 1 inch length, and this is the 3 inches length force. Now we have exactly the forces given in the problem according to the values given above, and the angles related to the shape and dimension given here. Now we start using the parallelogram law by drawing parallel lines to each vector here. So first we draw a parallel line. This line is parallel to this line exactly, and then we draw this parallel line which is parallel to this one. So in this case, by using this row, we can get the resultant vector just by connecting the point A by the point of intersection of the two parallel lines, or the dashed line as you see. So this will give us the value R, or the resultant of these two forces. Also, we can get the angle gamma, which is the direction of the resultant force. Now, there's a very important point. We come here to a very, very important point, which many students may confuse with. The value which you will get here is the length of this line, of this arrow, of this vector. But we actually want the value of the force. So actually the resultant of the force. So when you get this value, when we measure by the ruler, you will get 3.47 inches. This is length. It is not the value of the force. In order to get the value of the force, we should multiply again by the scale. But in this time, we put the value or the ratio of the force, which is 40 pounds here, in the numerator in order to get rid of the length units. So here we put it in a way that the two length units will cancel each other, and we'll get the value of the force unit. So when we multiply it, we get final the force unit as the result, which is about 138.8 pounds for the resultant of this problem. Also, by using the protractor, we can measure the angle, which is equal to 67 degrees. So this is the solution by using the parallelogram law. Now, let's solve this problem again by using the triangle rule, but we'll use the same scale, and we'll start by computing the angles. Why? Because in constructing the triangle, we will not be able to be or to use this shape, this triangle shape. So we will compute the angles. So this will be the angle alpha, and this will be beta. So in this way, alpha will be the arctan 1 over 1.8. here I use the scale of the paper. You can use the values given here. For example, 10/8, it will give the same ratio. So you will get or compute the values of alpha and beta, and then we start constructing the force vectors. So we have the same scale as we saw last time. So we here define the angle alpha, because the angle alpha is the angle between the vector or the direction of the force FAB and the horizontal plane. So here we have the horizontal line, and the force will be in this direction. So by using the alpha we can, and we know the length, which is by force scale, we can get 3 inches. So we construct the first force. Second force also in the same way. We draw a horizontal line, and from this horizontal line we measure by the protractor the angle beta, which is equal to 59.04 degrees, and we draw the line or the vector FAD, which is equal in length on the paper 1 inches. Now it's very simple to connect the point A with the FAD in order to get the resultant, as we did in the last method of parallelogram law, and we will get the same answer in both magnitude and the angle of gamma. So this is the solution of this problem. The second problem here, we have two forces are applied as shown to a hook support. So we have force of 50 newtons, which inclined by 25 degrees above the horizontal, and we have the P force, which have the magnitude is 35 newtons. So determined by trigonometry the required angle alpha if the resultant R of the two forces applied to the support is horizontal. So he gave us the direction of the resultant. It should be horizontal, and the corresponding magnitude of R is required also. Now, in order to solve this problem, we shall notice that we can use the triangle, the forces triangle simply. So by using the triangle rule, the triangle of forces can be constructed. As we see here, we start with the given value, 50 newtons, which is inclined by angle 25. And then we draw the force of amount 35 newtons. But actually we don't know this angle, but what we know that the resultant is horizontal. So we draw a horizontal line which represents the vector. So this is the triangle of forces. Now we can notice here that there's an angle, the known angle 25 degrees is facing or is opening against the 35 newtons force. So these are known, and we have here 50 newtons force side or vector which faces the angle alpha. So the angle alpha can be found by the law of sines. Very directly we can find it. So we have here 50 over sine alpha equals 35 over sine 25 degrees, and here we can get alpha equals to sine inverse or arc sine 50 over 35 multiplied by sine 25. Then we can get that alpha equals to 37.14 degrees. So directly we can get from the triangle. The section B is to find the resultant R the angle beta should be found first. So here we suppose that the angle which is facing the or opens towards the vector r is given beta. So here it's very simple because we know alpha now. So it's simply beta will be equal 180 minus 25 degrees plus alpha, and this will give us beta will equals 117.86 degrees. So now by using law of sines again, r, the unknown, over sine beta, which is known, over equals to 35 over sine 25 degrees. So simply we can have r equals to 35 multiplied by sine beta over sine 25. So r will be equal to 73.2 newtons. And this is the solution of this problem. In this problem, we have a trolley that moves along a horizontal beam, is acted upon two forces as shown. Now, here we shouldn't be careful that not to be distracted by the mechanism shown here. The students sometimes, oh my God, here's wheels and beam and trolley is moves. There's nothing to do with the motion. Here's nothing to do with the trolley as a moving part or moving mechanism. Actually, all our concern is the point A. So, question says, determine by trigonometry the magnitude and direction of the force P so that the resultant is a vertical force of 2500 newtons. So actually here we have nothing to do with the mechanism we see here with the trolley. Our target is the point A. So by using the triangle rule, because we see here we have three forces. One is 1000 or 1600 newtons force, and the unknown force P here, and we have the resultant, the known resultant, which is equal to 2500 newtons. And here all we have to do is to construct the triangle of forces. So first we start with the known value, which is the vertical resultant. Then we construct the known force, the 1600 newtons. Here we have the angle inside is 75 degrees. Notice, he gave us 15 degrees. So the 15 degrees with horizontal means 75 degrees with vertical, because the sum should be 90 degrees. Actually, we used the internal angles. Yes, we have 15, but the 15 will be outside the, if we draw it here, it will be outside the triangle, so it will not be useful for us. We need an angle inside the triangle. Finally, we close the triangle by the unknown force with the angle alpha. We see here alpha with the angle between the force and the vertical line. So here we are also alpha between the force and the vertical line. So actually, we can start solving this problem. Now, when we look to this problem, we first expect that we can use the law of sines. But the problem here, we notice that we have two unknown angles. So we know only one angle, which is 75 degrees. And this angle faces an unknown force. So here we cannot apply the law of sines, because if we try to put, for example, 2500 over sine beta, beta is unknown. If we try to put 1600 over sine alpha, alpha is unknown. So actually we have a problem. If we try to put P over sine 75, P is unknown. So actually here you cannot use the law of sines. So we should use here the law of cosines. So the force P can be found by using the law of cosines. So the law of cosines, we put the, we need to have the one angle, which is the angle opens or facing the unknown force or unknown magnitude or unknown side of the triangle. So we have cosine 75, which is facing P, and we need the other two sides only. We don't need the angles, we need the two sides. So we have 1600 square plus r square. We know the r is 2500, and minus 2 multiplied by 1600 r, and so on. So when substitute the values, we'll get and take the square root of the right hand side, we'll get this form, and thus P will be equal 2596 newtons. So directly, so this, the key to this problem is to know the law of cosines. So you should always take into consideration all laws of trigonometry, because they are very important in solving those problems, not only in this chapter or in this tutorial, but we will see for next or coming tutorials that the laws of trigonometry are very, very important in solving the problems of mechanics. The angle alpha can be found also by using law of sines this time, because okay, now we know the value of P, so we can use the law of sines, because here we notice that we have 1600, and we have the P value of P, and the one of the angle of facing it. So actually we can use the law of sines directly. So alpha will be equal the arced sine or sine inverse of 1600 over P. P is known here. You can use the angle or value directly. So the alpha will be 36.54 degrees. So this is the solution to this problem. Now, in this problem, again, don't be distracted with this structure. This is a structure which is shown here. We have Q. So always read the problem thoroughly in order to understand exactly what is wanted by the problem, because sometimes you have in the drawing you may see many things which can distract you. So never be distracted by the additional links or members or forces. The problem could be much simpler than what you see in the figure. So let's read the problem. Member BD, the member BD here, exerts on member ABC a force P directed along line BD, knowing that P must have a 300-pound horizontal component. Determine A, the magnitude of the force P, B, its vertical component. Now, we are concerned here with the point B. You can take the free body diagram of point B alone, but actually the force is exerted along the member BD. So we can start by drawing the forces on the free body diagram. This is a free body diagram. When we take a member and isolate it and take it away from the structure in order to see the individual forces upon its points, so you get the, it's called the free body diagram, or FBD. So here we put the forces, as you see here. So P is the force working along the axis of the member BD, and we take the point B because he says that the member BD exerts a force upon this member, so we are concerned with the point B. So all of we have to do now is to find the value of P, the force, the axial force along the member, by knowing one of its components, which is px, because he said that knowing that P must have a 300-pound horizontal component. So this is the horizontal component, and we know the angle. So the problem is very simple, can be found by using the trigonometric relationships. So we have the angle here, we have a triangle, so we can divide the value px. So the sine of this angle 35 here will be equal to the side, the front and side, over the hypotenuse, over the hypotenuse, which is the value of P capital. So sine 35 will be px over P, and it will be 300 over sine, then 35. So P, which is the value of the axial force along the member BD, will be equal to 523 pounds. The vertical component can be easily found because we have also this triangle, so we can find it by the tangent or tan of this angle. Please be careful here. Sometimes some students try to memorize the relationships just by knowing the subscripts or the components. So somebody says, oh my God, how the tan of an angle should be py over px, not px over py. You should be careful here, because here 35 is not the angle between the force P and the horizontal axis or horizontal direction. It is between P and the vertical direction. So that's why we put px over py in order to compute the value of tan 35. So this is very, very important. Never try to memorize everything. Just be careful in determining the position of the angle which are using or used in the solution. Now we can say that py equals 300 over tan 35. So py will equal 428.4 pounds. And this is the solution of this problem. In this problem, we have three forces given. So we have, knowing that the tension of the cable BC is 725, this cable, determine the resultant of the three forces exerted on point B. So again, we should not look to other components, but we should only concentrate on the point B, because in this problem we have a system of forces acting on the point B, and we need to find the resultant of the given system of forces. So here we have three forces. This means totally we will have 4 forces, because we have 3 given forces and the resultant. So in total will be 4. So in this case, and in the case of any other number of forces, such for example maybe 4 given forces or 5 given forces, in these cases we cannot construct, of course, the triangle of forces, but we can use the method by analyzing the the forces into components. So first we should draw the forces on the free body diagram of the point B. Then we can construct this table. Now let's see, what is this table? In this table we will find the components of each force in the x direction and the y direction. So let's see here. First we have the force of 780 newtons. So we should find the x component. In order to find it, we are given a triangle here which gives us the ratio between the horizontal and vertical, or let's say inclination of the force. So here we can use this value by finding the cosine of this angle, or the amount of the x component, by dividing 12, the horizontal component, over the hypotenuse of the small triangle here. So we will get the value 720 multiplied by I. I is the unit vector. It indicates that this force, or this amount, is a force or a vector directing towards the positive direction of x. So I here is a vector which acts towards the positive x direction, and its magnitude is equal to 1, to unity. That's why it's called unit vector in the direction of x. Here also we see the y component of the force 780. Now we should notice, similarly, of course, we can compute the amount, but here we use negative sign. The negative sign here because we notice that in the y direction, or in the vertical direction, the vertical component of this force will be directed downward. Downward means in the negative direction of the positive y. So that's why we put negative here, because we assumed that the positive direction of the vertical component should be upwards. So here we assumed, or we put the minus here, and j is the unit vector in the y direction. Same thing for the next 500 Newton force. Here we notice that the x component is negative because it is directed towards the left, which is the negative direction of the horizontal axis. We have also negative value for the vertical direction, minus 400, because it is directed downward. For the final value, the tension of the cable, here the tension always is directed towards, when we speak about the tension in the cables, the tension means that it directs, it tries to pull. Generally, tension means the pulling force. So imagine always that the tension is the pulling force towards the wall, and the opposite direction here, the tension at point C is a pulling force towards the beam. So actually the tension always is assumed to be a pulling force. So here we say that the direction of the tension in the cable should be in this way, pulling point B towards the wall, and that means this way it will be negative in X direction and positive in Y direction. Finally, we can get the sum of the similar components. So we have X components, we can sum of them algebraically, no problem. Can algebraically sum these values because they are in the same direction. Also, the values of the Y components can be summed algebraically because they have the same direction. So we get the sum of each part, and this will yield that the resultant are, in terms of components, in terms of ij components, or let's say x and y components, are minus 105 minus 200 j. Now, the magnitude of the resultant, so it simply can be computed by the square root of the squares of, or the sum of the squares of the two components. So directly we can get the value R equals 225.9 newtons, or 226. You can round it up, no problem. Theta, the angle, is tan inverse of Ry, that the j component, or the, let's say, y component over the x component, because we want the angle measured from the x axis. So in order to have the angle measured from x axis, we should divide the y component over the x component and take the arctan to get the value theta, and it will give us the 62.3 degrees. And here a pitfall, be careful, be careful. Here a very important point we should understand, that if you are asked to draw the resultant, you may think like this. Think, oh, okay, I can draw the resultant in this direction, 62 degrees. Oh, okay, I can do it like this. And this could be R. And this is wrong. This is totally wrong. Why? Because this means that the angles or the resultant of these forces is acted exactly in a opposite direction. How can you imagine? Because the resultant means the force that can be replaced, or that can replace the whole forces together. So when you put the vector in this direction, which force of these you see can produce such a vector upwards? Impossible. So how can we know the exact direction? There's two ways. There's two simple ways in order to know the direction correctly. The first way, it's very simple, is to use the x and y coordinates, because this is a force diagram. These are forces, and you can use this diagram in order to figure out the direction of the force. So we have minus 105 in x direction. That means in x direction it will be like this. So this is r x, and in the y direction also it's negative, so it will be downward and by double. So this will be ry. Simply their resultant will be something like this. So by using the components you can get the direction of the, this is number one. This is the simplest method if you have the two components of the given or the resultant. But if you don't have these two values, let's look to this equation of our calculate formula of theta. We notice here that in the numerator is negative and the denominator is also negative. So what is the tan of an angle? Tan is equal to an angle is equal to sine x, for example, over cosine x. Now, let's recall some idea maybe from the high school. This is a circle, by the way. I know it's not a circle, but let's assume it's a circle. Here, all all trigonometric ratios are positive. Sine, cosine, tan, all are positive here. Here in the second quarter, all these signs are positive. Here, the tans are positive. And finally, here the cosines are positive. Now, let's look here. Here we have sine negative, the cosine is negative, and tan is positive. So in which quarter here the sine is negative, the cosine is negative? Both. So here in this third quarter, sine is negative, cosine is negative, but tan is positive. That means the resultant should be in this direction, and this value 62.3 should be measured from the negative x-axis. That means you should measure it from 180 degrees. So this means actually that the angle from the positive direction of x-axis, theta is 180 plus 62.3, which equals 242.3 degrees, which are, as you see here in the diagram. So here theta is 242 degrees from x-axis if we measure it from the x-axis. So this is the point we should always take care about it, because trigonometry really is very, very important in solving the problems of mechanics. So, and this is the solution of this problem. Now, let's see this problem. Knowing that alpha is 40 degrees, determine the resultant of the three forces shown. Here we have three forces, 60, 80, and 120. Now, actually, we can solve this problem exactly as we did in the previous one, but I will change the method of determination of the components in a small way. So first, let's do the same thing. Let's draw the forces on the XY coordinate system. So we see here that the angle is 20 degrees because 60 is parallel to the inclined surface AA prime here. So its angle towards or between the force and the positive x-axis is 20 degrees. Here also we have 60 degrees for the second force 80 pounds because we know that alpha is 40, so 20 plus 40 is 60 degrees. And here we have the angle 30 degrees, but in negative direction, or let's say clockwise direction, because the positive is, we assume that the counterclockwise rotation of an angle is the positive direction. So we have clockwise, so it's negative, and the angle is 30. Why? Because imagine here, let's use my pen. Here, if I draw a vertical line, this is a line, by the way, never mind about it. So here the angle is 20, and this is 40. So the angle, and this is a horizontal line. So the angle with the horizontal direction is 30, because the sum should be 90. So this is 60. So 90 minus 60 is 30. So the angle between the force of 120 pounds and the horizontal direction is 30 degrees. So this is the way we obtain the three angles. Now, actually, we can say that the solution is easier, but instead of computing by using a table, I can compute every component individually. So we can take Rx alone and compute them by knowing the angles. Here we have 60 cosine 20 plus 80 cosine 60 plus 120 minus 30. Why? As I said, because here we moved in the negative direction. Be careful, because if you put 30 as a positive value, that means it will be above the x-axis. Also, we should notice something important, that if the angle is minus 30 or 30, in both cases, the value of its cosine will be positive. So never be confused. Maybe sometimes say, oh, okay, I can't put minus here, but I will put it instead of plus here. Be careful, this is wrong, because cosine minus 30 is equal to cosine 30. So the angle here will not be changed. Here also we can understand it by the sense of the when we take the component in this direction of 120's force, actually in both cases, even if the vector is downward or upward with the same angle 30, we will get the same component. So actually this minus sign will not affect this plus sign. So always be careful. Always get sure and be aware of the whole basics of trigonometry, because they are very, very important in solving problems of mechanics in general. Now, we get the values, and finally we get the value of the x component of the resultant, which is equal to 200.3 pounds. Now, the same way we get the y components, 60 sine, we use the sine, plus 80 sine 60 plus 120 sine minus 30. Here we should be careful, because the minus here will affect the sign outward. So this will be minus, the sine minus 30 will be minus 0.5. So that means, and this is very important, because we'll see here that the component will be downward. That will make the component downward. The other components are upward, because they're above the x-axis. The positive sides, they are in the positive side of the y-axis, but this value of 120 pounds will be directed, or its component in the y direction will be directed downward, because of the negative angle or its position under the x-axis. Now we compute the values and get the y component of the resultant. Now we can express the resultant in the components way, or the components notation, by using the unit vectors in the direction of x and the unit vector of the direction of y. And we notice that the final value is positive. Both are positive. That means the resultant will be above the x-axis. So its magnitude is 202.5 pounds. You can round it to 203, no problem. And the angle theta will be 8.46 degrees. Now we can show it here. Let me clean up the screen. So here we see that the resultant, I used the long vector in order to express the value of 205 with respect to the other values, and we have the angle 8.46 degrees, and this is the solution of this problem. Again, we have the same block, but this time the requirements are different. Determine the required value of alpha if the resultant of the three forces shown is to be parallel to the incline. So now the unknown is alpha. The resultant also is unknown, but the direction of the resultant is known. So the resultant will act in the same direction of the force of 60 pounds. Okay. The second requirement is the corresponding magnitude of the resultant. Now, here we'll use a different strategy. Why? Because if we make our analysis in the x, y direction, in the exactly horizontal and vertical directions, and the normal as or usual Cartesian coordinates, so we will have to add every computation of the angle the value of 20 to alpha. It will be very complicated calculations. So in order to solve this problem, it's easier to assume a local coordinate system, which is where its x-axis parallel to the incline AA prime. So we assume that we have x prime, y prime coordinate system, as you see here. Yes, we see that this is horizontal and this is vertical, but actually they are parallel to the incline AA prime. But in order to simplify the calculations, because if I draw it rotated 20 degrees, it will still make some confusion for you. So I think this is simpler, because we'll see how to get the correct answer just by this simple trick, if I call it a trick. Now, first we draw the first vector, 60 pounds force. Notice it is along x prime. This is x prime direction, which is, as I said, parallel to AA prime. And then by the angle alpha, we draw the second force of 80 pounds, and we draw the final force 120 pounds. Notice that alpha here is the angle between the vertical and the force, as it is here. So the angle between the force and the x prime axis will be 90 minus alpha. 90 minus alpha. Okay. Now, since the resultant should be parallel to the incline, like this, as you see here, so that means the resultant, as I said before, will be in the same direction of the 60-pound force, so it could be drawn like this, no problem. Yes, we don't know its magnitude, but we know its direction. It is in the direction of x prime. Then we know that tan theta prime, where tan theta prime is the angle of the resultant with respect to x prime, is equal to ry prime over rx prime. We express everything in the with respect to the new coordinate or the local coordinate system. Now, the angle of the resultant with respect of x prime axis is 0, because we see here there's no angle between r and x prime. So the y prime here should be 0. Y prime should be 0. Why? Because in order to have tan 0, the y prime, the numerator here, would be 0. If the rx prime is 0, tan theta will be infinity, which that means that theta will be 90 degrees. And this is not the case. This is the case if he said that r is vertical. If r is vertical in y prime direction, yes, that means rx prime that time will be 0. But here, r is in the x prime direction, in the horizontal direction exactly, and thus the value of ry prime should be 0. Thus we can write this equation, write the sum of the forces in the x prime direction in this way, and equate it by 0, because this component will be, or vertical component here, is 0. Now, sine 0 is 0. Again, I will use my pen, although it's not so much elegant, but anyhow, so this is 0. And we need the value of alpha. This is unknown, so we will keep it here. And here, this will be equal to alpha minus 90. And there is a rule in the trigonometry. Sine alpha minus 90 is equal to minus cosine alpha. So this is one of the rules of the trigonometry, that when we have, let's say, the alpha minus 90, any angle, when we subtract pi over 2, and we get the sines of this angle, so actually it will be equal to minus cosine. So this will be the resulting formula. Now, by dividing both sides by cosine alpha and transferring to the right hand side, we will get this formula, which tan alpha will equals 180. Thus alpha will be 56.31 degrees. Now we knew alpha, so no problem. We can compute the value of the or the magnitude of the resultant force by using the x component, because now we know that the resultant has only x component, since its y component is 0. So r will be rx prime, which is equal to 60 cosine 0. This is 1. This is equal to 1. And so this will be in cosine alpha. We know alpha now is 56.31. And cosine minus 90 minus alpha. So here we don't have to look for a rule of trigonometry, because we already can compute this value, and this will give us the value of 204.23, and thus this will be the magnitude of the reaction, of the resultant in this problem, and this is the solution of this problem. Here we have another type of force system problem. This is equilibrium problem. It's not by resultant, by equilibrium. The equilibrium means that the force system exerted on a part or on a body actually keeps that body in equilibrium, in balance. It won't move in any way because all forces altogether will balance or put the body in a condition of equilibrium. This is the idea. So here we don't want to find a resultant, but actually we can find the values of unknown forces by finding a general condition of equilibrium, as we'll see, and we apply it to the forces, maybe as a triangle of forces, sometimes a polygon, and sometimes, as we'll see here, as components of x and y. So let's start solving this problem. Two forces, P and Q, are applied as shown on an aircraft connection. Don't be distracted. Aircraft connection or any connection. You don't have to be a student in the aerospace department. This is simple mechanics problem. So knowing that the connection is in equilibrium and P is equal to 500 pounds and Q is 650 pounds, determine the magnitude of the forces exerted on the rods A and B. Now, first of all, let's step by step construct the or put the forces, because we have a point here where the points coincide together, so we can represent the forces on xy coordinates in the horizontal and global xy coordinates. So first we have the force Q, which is inclined from the vertical by 40 degrees. That means it has angle of 50 degrees from the horizontal or x-axis. We have the vertical force, which points downward, P. We have the force Fa, which is along the vector of Q. So we have the angle 50 with the horizontal, but actually in calculations we can use the angle 130 here. So, and finally we have the force Fb, which is horizontal. Now, because of the static equilibrium of forces in the x and y direction here, the x and y, let's say x and y here, I forgot to put y. First we start with the equilibrium in the y direction. Here, this notation means that the summation of all forces in y direction is equal to 0. So the whole components, when we sum all the components, if the connection or the body is in equilibrium state, that means the whole forces should be the sum of the forces, regarding of course their directions, because if they're in opposite directions should be negative and so on. So the sum should be 0. And here we use this notation in order to say that we consider that the forces acting upward as positive, and those were consequently those are the downward or acting downward are negative. So this is the main idea here. Now let's start with the Fy, or the y components. So here we have FA sine 130. We get the y component of the FA. So we use sine 130 minus P. Actually, P here is directly can take it. We don't have to say plus P sine 270. Actually, it's or minus 90. We don't need, because already by default we see that it is directing downward. It's exactly opposite to the direction we considered as a positive, so we don't have to make sense. If you want to do it, okay, it's not wrong, but you should be careful that we should say plus P sine 270 or plus P sine minus 90. This is very important. Now, plus Q sine minus 50, because, as I said, this is in the direction downward. So, also could be Q sine 310, by the way. Maybe somebody wants to compute it from the positive x direction in the counterclockwise, so it will be 310 degrees. It will lead this. It will give or yield the same value anyhow. Now, here, because these are known, P is known, Q is known, so we can simply compute the value of FA, which will be equal to 1302.7 pounds. Now, then we can compute the value or the equilibrium equation of Fx. Now we see that we have the summation of the all x component of the forces should be 0, and we consider the positive x direction as the as positive value. So any force in the direction to the right side or to the right in general, it will be considered positive. Now, you may ask why I started by y. I didn't start by x. Actually, just a simple look to the diagram here, or the forces distribution. You notice here that the force Fa will have two components. One in the y direction, the y, and the other in the x or negative x direction. So if I started with the summation or the equilibrium equation in the x direction, this equation will give me two unknowns. So I preferred to start with the equilibrium in the y direction, because in the y direction I know the FB is totally horizontal, so it will not have a y component. Thus, the only unknown in this case was FA, so we determined directly, and then we can now use FA in finding the value of FB. So again, with the same way, FA cosine. This time we use cosine because we are analyzing the direction. So actually we have component cosine 130, the same angle, no problem. We have cosine minus 50 here. P, here we don't have P because it has no horizontal component at all. It's vertical force. It cannot be analyzed to x direction. So this is the equation, and finally we can get the results that FA equals 1303 pounds and FB equals 420 pounds, and this is the solution of this problem. Here we have an interesting maybe a problem in shape. So he says a sailor is being rescued using a boatswain's chair that is suspended from a pulley that can roll freely on the support cable ACB. So we have support cable ACB, this the thick one, the lower one here is the support cable, and is pulled at a constant speed by cable CD. Here we should not be also distracted by the constant speed. Here this piece of information actually says that the forces are total static. There's no dynamic forces here. So the problem is related to statics. It's not related to dynamics anyway. So this is the meaning of this constant speed remark. Knowing that alpha is equal to 30 degrees and beta equals to 10 degrees, and the combined weight of the boatswain's chair, this chair, and the sailor is 900 newtons, determine the tension A in the support cable ACB, thick one, and B in the traction cable CD. Now, although it seems to be a bit, let's say, confusing problem, but actually it's very simple. Why? Let's see here. If we combine, because we notice that the left side of the pulley, the left side where we have AC and DC cables, the two cables are parallel. So at the beginning of the solution, we can combine the tension in these two cables. So we can do it like this. We assume this is the point C here. It's the point C. So here we can say that this vector represents both TAC and TCD, where T is the tension. Remember, as I said before, tension is always pulling. Is always, imagine that if we want to need the tension inside this wire, that means the wire is pulling this point towards the edges. So the tension is always in the directions with pulling to other sides. Now again, we add the tension. BC is one wire, no problem. And then we have the weight, combined weight of the sailor and the chair. Now, from this figure, we can directly draw the triangle, the forces triangle, or the tensions triangle, correct. So here we transfer this combined tension vector here, and we have 60 degrees. Why? Because we have 30 degrees with horizontal, that means 60 degrees with vertical. Remember, always we need the internal angles of a forces triangle. So here the value of 60 is obtained between the vertical and the combined tensions. Here, if we draw a horizontal line, so this will be 30 and this will be 10 degrees, so there are 40 degrees. And finally, this angle could be found by subtracting 40 plus 60 from 180, because total angles of a triangle is 180. Or if we take a horizontal line, this is 10 degrees, so 90 minus 10 will be 80. So in these cases, we can get the angles directly. Now, we have the three angles, all of them. We have one of the forces, so simply we can apply the law of sines in this way. TAC plus TCD, the combined forces, tensions, over sine 80 let me clear up the screen for more clear view. So here we have 900 over sine 40. We have TAC plus TCD over sine 80. And we have TBC over sine 60. So this is the, now we can simply find any pair of these angles. So TAC plus TCD, we start for this one, was 900 multiplied by sine 80 over sine 40, which is equal to 1378.9 newtons. And we can compute now the TBC, so the tension in the support cable. TBC is equal 900 sine 60 over sine 40, which is equal 1212.6 newtons. Now, since here's a very important fact related to the pulleys, and this you will come across to this fact the whole of your whole study of statics and dynamics, because there's many problems of pulleys in statics and dynamics. So the tension is equal in the support cable in the both sides of a pulley. If you have a pulley and the tension in the cable on the both sides, regardless of the angles. So, for example, here we have 10 degrees, we have 30 degrees. That will not change anything. The fact is that the tension in the cable ACB is the same, is one value. So that means the tension in the part BC is equal to the part AC of the same thick cable we have, the support cable we have. So TAC is equal to TBC. So we can simply now get the tension in the traction cable, because we can say that TC, because we have combined values TAC plus TCD, so TCD will be equal 1378.9, value obtained here, minus the TBC 1212.6, which is equal to 166.3 newtons, and this is the solution of this problem. In this problem, we have several mechanical components. A weight, we have a cable, we have a pulley, a collar, we have a beam. Actually, it seems to be a compound problem, but actually it's very simple. So always never be distracted with the number of mechanical components you can see in the problem, because sometimes it's very easy, very direct problem. So you should read the text well and understand what is required by the problem. So here let's read the text. Collar A is connected as shown to 50-pound load. Notice here it says 50-pound load. So this is the force. We can use it directly. We don't need to multiply by the by G, the gravitational acceleration value. This is the force given directly, because he says load, 50 pounds load. Now, can slide on a frictionless horizontal rod. Here, frictionless means that there is not any other force can resist the motion of this slider here. So that means we don't have any other force other than P. shown here, and the effect of the tension of this cable. Determine the magnitude of the force P required to maintain the equilibrium of the collar when x equals to 4.5 inch and x equals 15 inches. Now here the value of x, and we have the height of distance between the center of the collar or the path of the collar and the let's say the point or the axis of the pulley. Now, in order to solve this problem, let's draw the free body diagram of the collar. So here we have the collar alone. Now we put the forces. We have P and we have the tension. Again, the tension always pulls. Yes, we don't have the arrow here. We don't see the arrow, but we know that the tension always pulls the components towards the cable or the other side of the cable. So we have the tension here. Now we get components. We have the horizontal component Tx and the vertical component Ty of the tension, and we have the ratio of the distances of 20 to x, or x to 20. This is the ratio. Now, first, again, the fact that we knew last example, that the tension is equal to both sides of the pulley. That means that the 50 pound which is the tension in this side of the cable, is the same tension as the other side of the cable. So we can say, since the tension of the cable is equal on both sides of the pulley, T will equals to 50 pounds. So here T will be equal to 50 pounds. So we know the value of T. Now, the collar is in the static equilibrium in the horizontal direction when the sum of the forces in the x direction is equal to 0. And we assume that the positive direction is to the right. So we can write this simple formula, or the simple equation, because here we don't have except P and Tx. So minus P, because it's directed to the left, plus Tx to the right equals to 0. Now, how can we compute Tx? Oh, how can we find Tx? Actually, we can find it by using the cosines. The cosine of the angle, if we assume, for example, an angle here, again, I will use my elegant pen here, the angle theta. Now, if we want to take the component of T capital, the horizontal component, which is Tx, now we'll use the cosine, which is equal to x, because this is a rectangle, so x over the length of the vector t, or because this is a triangle, so it will be value of x over the hypotenuse, which is equal to the square root, according to law of Pythagoras, is x squared plus the square root of the x squared plus 20 squared. So this is the formula. Be careful. Never divide by 20, because sometimes we'll say, oh, okay, it's x over 20, we can get. No, be careful, because x over 20 will be the tangent of the angle, not cosine. Here, in order to get the component, we need the cosine. The cosine is equal to x over the length of the hypotenuse, or the square root of x squared plus 20 square. Now, by substituting the value of t and rearranging this equation, we can get the general formula as p equals to 50 x over the square root of x squared plus 20 squared. Now, in case of x 4.5 inches, we can substitute the value 4.8 and we get the value of the force P 10.976 pounds. This is the case when the angle, when the distance here is very small. When we have large distance, which is 15, in case x equals to 15, so P will be equal to 50 multiplied by 15 over the square root of 15 squared plus 20 squared, and we'll get the value of 30. So the key to this problem is it's very simple. It's related to trigonometry, but you should be careful when you find the relationships. So this was the last problem in this video tutorial. I wish you would enjoy these series of tutorials. Please subscribe for upcoming video tutorials. If you like this video, please give me a like. Thank you for watching, and goodbye.